associate professor in the Department of Chemistry and Biochemistry, and I've been here since about 2003. My research and teaching interests are based on environmental and analytical chemistry. Specifically for research, I'm interested in wastewater, how you can treat wastewater, and sustainable energy-related or sustainable, actually, development-related projects around water.
Okay, very nice. First question is, where does DU's water come from?
Well, I'm pretty sure that DU's water, we're part of the city of Denver, and so it comes from Denver water, as far as I know.
Okay.
We do have some interesting old water rights on campus,
yeah.
but I'm pretty sure that our water comes from the city of Denver.
Perfect.
Denver water.
Are there any problems or potential problems that could arise with water quality here on campus? Why or why not?
Yeah, so Denver water, which I should go back and say it's not associated with this, it's not necessarily the city of Denver, but it's Denver Water, which is an independent organization. Last year it was like the best tasting or second best tasting water, and it had the highest water quality nationwide. So it was, it's pretty good water from that standpoint. So the source water coming to the university is of the highest quality probably, and technically from a taste standpoint, many people think it tastes pretty good. Obviously that changes where you're from. Some people are from areas where have a harder water or softer water, and they're used to a different taste. But from a water quality standpoint, it's of the highest in the country.
Nice.
Now, once it gets to the university, that could be completely different, right?
Yeah.
I think the university's been very proactive in many areas around campus, but there's always the potential. There are some old water fountains on campus that you go and you try to get a drink from. They taste kind of sketchy or funky, and that's really just the process of aging pipes.
Okay.
And so the water can come in pure, but then when it comes to old infrastructure, sometimes you have water fountains that are kind of less than palatable.
Okay.
If that makes any sense.
That does. So, if I'm aware, a few years back, you and another scientist by the name of Jay McGrew,
Correct.
Came up with a new method to remove sewage from Colorado's water. And so, could you briefly explain Colorado's current wastewater treatment process and how your invention may improve that process?
Sure. Well, in general, the major metropolitan areas in Colorado treat water the old, conventional way. It's all above ground, large wastewater treatment facilities where you have anaerobic and aerobic type of digesters. You have different levels of treatment. So you're basically using bacteria and a series of separation mechanisms to clean up the sludge, the sewage sludge. Right? Well, I mean, yes and no. Most of it's biological, actually.
Oh, yeah.
Most of the work is done by the bugs. Biological, engineered through different types of, again, aerobic conditions, so with oxygen and without oxygen, to remove as many of the solids material, right, in sewage that you have. There's some mechanical things too. When sewage and surface water runoff comes in, they remove loops and stuff like that. That's huge. But in general, a lot of the wastewater treatment is done with microbes.
Okay.
And it's not until the very end of the process, depending upon where you are, at least in the major metropolitan areas, where they begin to introduce chemicals. Those chemicals come at the very end when you're trying to disinfect the sewage before you dump it into the surface waters. Because most of our water then, after it's treated, our sewage is dumped into surface waters. Discharged is a better name, right? So that's where the chemicals come in. And over the years, they used to do it with chlorination, chlorine gas, which is pretty dangerous to keep around. But I think in general, if I'm not mistaken, all of the major wastewater treatment plants have removed chlorine gas from disinfection.
Okay.
So you don't have those dangers around. So there is a last chemical component, because you're using bugs, right? You're using microbes to digest the sewage, and so you want to kill those before you discharge them into the environment. So that's what that last step is. Different wastewater treatment facilities use different techniques. Some use chemicals, some use ozonation, which is just ozone, which is very, can disinfect very well. Some use UV light at different stages. So there's just not one type of wastewater treatment. It actually varies a wide spectrum.
Okay. And what is your invention called again?
So it's really not my invention, actually. It was Jay McGrew's
Okay.
invention. It's called a vertical tube reactor. And what the vertical tube reactor does is it uses a process called wet oxidation. And just I like to think of it as an automobile engine. You you take an organic material, fuel, and you add oxygen, you heat it up, and it forms carbon dioxide and water. And in that process, gases expand, and when the gases expand, that drives the piston, which drives your engine, right? You can do the same thing with sewage underwater. You can add water, and well, the water's already there, sorry. You can add oxygen, add heat, and at certain temperatures, the organic material in sewage will react with the oxygen, generate its own heat, and produce carbon dioxide and water.
Okay.
So that's the simplistic standpoint.
Yeah.
Ideally, that would happen. And so what this technique does is use his invention does is use that process, and what we do is we inject the sewage with air from the surface underground. It's not underground, it doesn't go there, it doesn't go dissipating throughout, but it's just a big encased reactor, if you will, like a big gigantic pipe about 8 to 10 inches wide, and the sewage goes down the inside with the air entrained, and the idea is that now you have oxygen from the air, and then the sewage, and at the very bottom of the reactor, which can be 3/4 of a mile down, because we need that pressure to keep everything in a liquid form, the sewage reacts with the oxygen, and by the time it comes all the way up on the outside, then it's been treated and disinfected.
And with all these gallons of water pumping through, how much can your machine take, or Jay?
So the invention itself was tested in 1980, a long time ago, right?
Wow.
But it was before its time, really. There wasn't a fuel crisis, there wasn't a water crisis in the West, and so it at the time was treating all the sewage from Longmont, Colorado, just north of Denver. And then it was taken, the whole thing was removed, and then went out to the Netherlands, where it operated for another 20 years, treating multiple waste around some towns. So I didn't answer your question, but basically one of these small reactors, which would probably take up the footprint, maybe this big room here, so not a lot of space, because most of the work is done underground, right?
Exactly.
Would treat maybe, I think his current design was 50 to 75,000 people. In other words, the sewage from a city of 50 to 75,000 you could treat. But the advantage here is you could imagine building multiple of these reactors on a small site, all the treatment's done underground, and you could end up with 3 or 4 of these treating major metropolitan areas in the United States and worldwide.
And last question for you. What are your hopes for you and your colleague for this project in the near future? Has it been implemented?
So implementation, that's the hardest part. It's
Exactly.
It's non-conventional. It's not the conventional wastewater treatment, biological, microbes. So there is the buy-in from the wastewater treatment community. Is it really viable? There are some challenges, right? Your reactor is all the way underground, it's buried underground. If something breaks, it's hard. You have to lift the whole thing up out, and putting it in place is pretty difficult. So there are those technology challenges. But our hopes are that we're to treat waste from a standpoint of maybe internationally, where there are so many large population, high density cities throughout the world that are really begging for a wastewater treatment process. So right now we're working through some nonprofit connections to go internationally, to look to see if we can make inroads on an international level. Because the U.S. is so caught on infrastructure with above ground that they're kind of resistant to take on this technology. But Asia and Africa, we're hoping through some nonprofit connections that we can make some inroads there. The trick is going to be another pilot project. It worked well in the 80s. We demonstrated, he demonstrated that it worked well in the 80s. And now it's just trying to get people, to look at energy costs are going up, water consumption is going up, and both of those come to head. And the great thing about this technology is it combines both of those. In other words, while you're treating the water, it is exothermic, which means it releases energy. And so in that process of releasing energy, you actually have to remove heat. If you don't remove heat, the water boils underground and you have a disaster.
Wow.
So in the process of removing heat, you can power the pumps that pump the sewage through the reactor and still end up with extra energy.
Oh my.
So you can end up generating energy from treating waste.
Yeah.
And that energy you can capture and you can use it to heat greenhouses, and you can use the water that you've treated to grow plants. So that it's really a really novel technique. Not that it hasn't been done above ground. There's actually some of these techniques that are done above ground. There's one in Massachusetts, a wastewater treatment facility that does the same chemical process above ground. But it takes so much energy to encapsulate this device above ground. And when you put it underground, you have this wonderful insulation after you heat up the ground that you don't have to worry about many of the pressure constraints and the engineering constraints you do that. So, I mean, our hopes is that, you know, in a bad way, that the impending water crisis and energy crisis, I think we have a technology that helps in both of those areas, and that people will invest in.
I think so too. All right, thank you so much for
You
your
bet.
time.
Thank you for your time. Appreciate talking to you.
Appreciate it.
All right.
Thanks so